Welcome back all, I'm Dazzy J from Model Techniques. This week we got Geoff BUNZA from Portland, Oregon. His specialty is animation on model railroads using Arduino and Raspberry Pi. Don't forget to subscribe, like, comment below. Also, I've got a Patreon page. Thanks for a big shout out for all my Patreons out there and super fans. Every little bit helps to keep the content rolling. So without further ado, let's get started. Up and running is MRT scale print. So if you want Craftsman quality 3D printed prints, email me below. Welcome aboard, Geoff BUNZA, and welcome back to Model Techniques this morning in Australia and evening in the US of A.
That it is.
Let's get right into this. So you can be found, you got a lovely blog on Model Railroad Hobbyist, and I'll put all the links to everything below. You got a YouTube channel under the name of Geoff BUNZA as well, and of recent times you're doing some lovely videos for the Model Railroad Academy. Is that correct?
No, not Model Railroad Academy, but Train Masters TV, associated with the Model Railroad Hobbyist magazine.
Right, so my apologies for that, and I will link to that below. So can you tell us a little bit about what you're doing there?
Well, I should probably, over the course of 6 or 7 years, I've been doing variations of animation clinics. And when I'm at a major conference and I have the energy, I've been doing three: modeling, modeling with light, modeling with sound, and modeling with movement, all part of the animation series. I've added things onto it every time to try to keep it fresh, and if people come back to it a second time, they see different things. And for the MRH thing, they're recording each of those clinics that I have been evolving, and I took bits and pieces of another set of clinics having to do with Arduinos and sequencing for animation, because I had embedded a lot of that in each of the other clinics, and so we expanded on that. So the 4 clinics for Model Railroad Hobbyists will be modeling with light, which is the first one, modeling with Arduinos, which is not about Arduino programming, and then modeling with movement and modeling with sound. And the way things are wont to be with Train Masters TV segments, there'll be 2 or 3, more likely 3 segments per clinic. Yeah. So that's what I'm putting together now with them. We've got the first 2, modeling with light, modeling with Arduinos in the can, and they're going back and re-editing them, taking out all the dumb things I say, which is a real chore.
It's normally the dumb things I say, so that takes me a while as well. So, but that's fine. Now, unified field theory we're going to talk about quickly. I think it was astrophysics last time. Unfortunately, I had to cancel our interview last week because obviously a health issue. So I've got to pay 20% more. So this interview is going to go 20% longer. So that's where we'll start. So we'll just we'll leave that there. So now I'm slowly going through your clinics, your blogs, your videos, and I'm just in awe because I'm just an Arduino microprocessor noob using a. Sorry, what's going on here? No, that's fine. I'm very much a beginner, I suppose, in my neck of the woods, trying to learn the Arduino side of things. So we're talking, some of the stuff we'll talk about in this interview, I think, from my point of view, is high end, which is, I just love what you're doing here in this space. But I think we need to drag it back a little bit for people like myself. Arduino basics. So we'll start there. Where would be a good place for someone to start their Arduino journey?
Well, if you're a modeler, I'd actually recommend the article that I had in a I think it's December 2016 issue of Model Railroad Hobbyist. It's called um, uh, Introducing Modelers to our to Arduinos. And the reason for that is that's written fairly differently. It's first off, it's written in light of trying to get a modeler to use Arduinos, not to learn how to program them and about the innards of them. So my contention for quite a while has been that the easiest way to lose modelers is to try to tell them about the technology of Arduinos. I think it's far better to consider it a tool
Mm.
and give them the basics of how to use the tool and get up as fast as possible with it. And then if they want to go further with it, there's some really obvious things that they can do to tweak it, to manipulate it, to make it their own. And that was my approach in the article, A Modeler's Introduction to the Arduino. And that's typically when I talk to modelers, that's my
Sure.
approach. The vast majority of people doing modeling with Arduinos or, for model railroaders or whatever, they sit down and they're trying to tell them, okay, here's, Arduinos are kind of computer, and here's how you instruct it, and here are the instructions. And my tack has been uh, to provide a rather large number of pre-done what are called sketches in the Arduino world, which are programs. The Arduino started because it was meant to be a teaching tool that was developed by a group of Italian teachers. And they wanted people to understand computers and learn how to program them. So their tack years ago was to make everything open source, which means they provide everything about it, meaning if you want to build your own, you can build your own. They give you all the details, all the components, all of the constructs, the layouts for the boards. But they also decided that all of the software for it was going to also be open source. And that meant that they were going to freely make it available to anybody who wanted to use it. Now that's great because it literally
Mm.
exploded. There are a minimum of another dozen small microprocessors that have been around in the same time frame. Uh, and the processor that the Arduino used was made by a company called Atmel, ATMEL, that subsequently has been bought by another company called Microchip. Still available, still useful, and Microchip is also encouraging the use of Arduinos. However, it's evolved. There are now lots of varieties to use in terms of the hardware. And the whole idea was to make it so simple to use that you could buy the hardware pre-built. If you wanted to add on to it, there are add-ons to it called shields that you can literally plug into. And only by using different libraries, you can make these add-ons worthwhile and workable. Okay, within that context, my idea with relative to models and my pitch has been you can use the hardware that's presented. And if you go and find the sketch to do what you want to do, just load it and know how to hook it up. So, in virtually every article that I've written, anything that I've talked about, all my clinics, I typically will say, okay, here's a library, or here's a dozen or 2 dozen sketches of how to build things and what you can do with them. So it's everything from blinking lights to moving servos for switch tracks uh, to operating motors to even building your own DCC system, base station, your own decoders, and lots of variations in between, together with animations uh, for specific projects. And, I'm using these myself, so it's really easy to share once you kind of provide the ground work for here's how you power the hardware, here's the hardware, here are the variations you might be interested, here's how you hook it up, and here's literally how you load the pre-built software called sketches onto them. So model railroader is also, I think, very lucky that many people have adopted over the last 6 years plus the use of Arduinos, and there are lots of sketches that are out there that fortunately people have also made available and shared. So mine aren't the only ones that can be loaded. There are dozens and dozens and dozens of
Mm.
libraries and other people who have gone and done it
Yeah.
successfully. So there's lots of things that you could do to use them. And once you understand how to power them, hook them up, download the sketch to them, you know, the world opens up. And that's really my pitch and what I've been trying to
Yeah.
do
Sure.
is to open up the world.
No, you def.
And if somebody wants to learn the technical innards of it, that's great. There are a million tutorials on the net. There are model railroaders, in fact, that have really quite good videos, and there are several people that have made them available on
Mm.
YouTube. And some of them are very good, some of them are terrible, kind of dry, but some of them are very step by step, uh, carrying you every step of the way. So I kind of jump started it by uh, if you know how to put it together, you know how to load it up, you're good to go. And you can actually, uh, in the clinics that I've done with hands-on with Arduino, by the time people leave the clinic after a couple hours, uh, sometimes they'll have their own DCC base station based on Arduinos. They'll be able to operate servos. They'll be able to operate motors. They'll be able to do marquee lighting, beacons, searchlights, all kinds of
Yeah.
stuff.
Nice.
And then they can go and take off with it in lots of different
Yeah.
directions.
Lovely. Lovely. No, you're definitely right there. It's something that I've jumped in feet first, I suppose, with your help. So thank you very much, Geoff. Um, my little crossing gate's working quite nicely now. So that's one thing I have learnt. You got to be a little bit careful when you're buying the cheap knockoff Chinese um,
Uh,
add-ons, like a little MP3 player. That was the issue with it. I went
yep,
and bought
yep.
another version. A friend of mine did another crossing gate, and I got the exact product that he did, and it works perfectly. So whether there was something wrong with the ones I got, I don't know, or they got to be programmed differently, I don't know. So just be mindful of obviously that side of things as well. That you
Yep.
can pay. You're not talking a lot more money, but it might be only a few dollars here and there. But you're guaranteed to get a better piece of componentry. That's one thing from that I've learnt. And you're exactly right. I'm not so much into the programming of the sketch side of things yet, I don't think. But you're exactly right. And there's a question a little bit later on in this interview about repositories and the likelihood of that side of things, because there's some lovely sketches out there to do just about whatever you want to do, and it's almost the third or fourth dimension of model trains, isn't it? So we've got the trains moving, we've added sound, we've got moving cars with Falla systems, and obviously you've done your own little steam shovel as well. But the lighting of buildings and animation in buildings that is getting done, particularly by yourself, Geoff, is just absolutely fantastic. I'm actually looking at doing a basic series. Last few Christmases ago, I built a little German German village with a Christmas market on it, and it's just got lighting that turns on and off. That's it. But I think I want to go that one step further and sort of animate that a little bit with some of your sketches.
Yeah, that's great. I mean, there's so much you can do. One of the great things about model railroading really is that there are so many pockets of interest that you can build a sub
Yeah,
hobby in. Even consider like 3D printing today. Man, just to get to the first 3D print requires a lot of learning. But once you get there and open that door, I mean, it's a fascinating new world to go and use in modeling. But there's so many other dimensions to it as well. I mean, even simple soldering can take off in a to build metalwork in your models, to do electronics. I mean, it's really a fascinating subset. That's one of the great things about model
No, you're
railroading.
definitely right there. I think I'd say it on just about every interview that I do. I think this is the ultimate hobby, just purely that fact. There's electronics, woodwork, there's history, there's economics if you want to get into operations, how model trains were run in the day, and it's just sort of everything in between. That's probably just not limited to just a few little examples of what this hobby can give us. So you're exactly right there. So
Absolutely,
now
absolutely.
let's dive quickly into some of your undertakings. Now I've cheated here a little bit. If I can use the hobbyist now, let's talk about the 17 channel DCC decoder that I stumbled across. It's a few years old now. Can you sort of talk us through the design, because it's something that I think I'm going to get myself into, because it's like, it's the electronic skills required. I think as long as you can sort of half reasonable solder and you can get your hands on the printed circuit boards, I think is half the battle with this one by the looks of it.
Yeah, this actually started as a very simple thing. I wanted to use a DCC control to turn on lights. That
Yeah,
was it, right? And I had been using the Arduino Pro Mini, the little blue board in the picture, and it occurred to me that there may be a way to get it to go and decipher the DCC signal. So I started poking around, and I actually wound up not building a decoder first, but actually building the equivalent of a base station.
right.
There used to be a library that was available called no, Commander, DCC Commander. I can't remember the name of it. It was like DCC Commander. It was a while back. I actually have a couple of articles written about it. And the gentleman who was behind it abandoned it, uh, but I had used it for a number of things, and started to build little additional PC boards to attach to the Pro Mini, and had gotten to the point where I thought, if I've got the ability to generate the DCC signals rudimentarily, why not build a decoder? And again, the original decoder was just to turn on a bunch of
Yeah,
lights, in this case, LEDs. And I started poking around, and sure enough, there were some people who had built uh, some software for Arduinos. I think there were three different sets, and generally speaking, they were terrible. Uh, but I got to the point where I could actually connect the circuit up and to a DCC bus, and I was getting actually terrible results, inconsistent results, would probably the best way to put it. And I wound up connecting with a library called NM, NMRA DCC or DCC NMRA, whatever the library is called, which was written originally by Alex Shepard in New Zealand.
right.
And Alex is a brilliant programmer, great guy. Been around trying to do NMRA standards and specs with DCC, was involved in LCC in its original inception, and just a great guy. Anyway, he had written this NMRA DCC library that nobody seemed to use. And I found it, and it was kind of languishing. And he'd already gone off, I think, to do either LCC or continue to develop the library to do a direct connect to LocoNet, the Digitrax internal network. And I got a hold of this thing and started playing with it. And lo and behold, it started to function. And I started to push it a little bit and this and that, and started to modify it, and got it to work with turning on a single LED. And the problem that I had originally was that even though I got it to turn on and off LEDs, uh, the interface to the DCC bus was terrible. I mean, just god awful. And I had all kinds of noise problems, even with just 2 foot runs from my Digitrack space station to the decoder. Lots and lots of noise, lots and lots of problems. So I worked on the interface to DCC, the DCC bus, literally the hardware interface that's on the left-hand side of the decoder, adjacent to the Arduino Pro Mini. Got the thing to work after about, oh, I don't know how many months of futzing with it. And uh, made a connection with Alex, who I started asking him some questions, and he made some modifications to the library, which made it even work better. And I got to the point where I published the first lighting decoder, and all, like I said, all it did was turn on and off LEDs. But I looked at it and said, well, why not use all the pins on the Pro Mini? And that gave me 17 pins. There are 18 worthwhile pins, and I needed one to read the DCC bus. So I wound up with 17 control points. So I had 17 LEDs to turn on and off. Well, that was great. And I published that. And that was the very first article. And then I didn't realize, and by the way, this is the one thing that I am terrible at, which is predicting the interest level of my articles and projects. I was inundated with requests for could it do this? Could it do this? Could it do this?
Yeah.
Uh, and the very first decoder that I actually put out was all hand wired on a little perf board, and the parts cost for me, I think, was like $4.83 or something. It was less than $5. So I titled it uh, "Build Your Own DCC Decoder for less than $5," and that apparently hit a nerve. Uh, and then when they found out there were 17 functions, they kept asking, well, what I really want to do is I want to not just turn the LEDs on and off, but I want to blink them and I want to pulse them. And could I use it as a pulse to actuate the solenoid for a switch track? And then, of course, once they got into that mode, they started saying, well, why couldn't I drive a servo? And I had not played with servos very, very much and got a few of the really cheapies and started looking at it and said, well, uh, if I did this right, I ought to be able to configure each one of those 17 pins to do a different function. And let's see, at last count, depending on the decoder sketch, I think you can get up to 7 major functions per pin.
Wow.
But there's actually with the entire library, it's probably closer to 10 or 12. But some of them are exclusive. Well, you can't use some with in combination with the others.
Right.
But with the 7, you could select a function for each pin. You could set it up via the CV and the decoder, and you could literally program the function into each of the 17 pins. And one of them was servo control. Well, the servo control was like wildfire. I mean, it just went completely nuts. Uh, and I had requests. The first time I had a request from Italy, I was really surprised because I figured, well, nobody's going to read this stuff, right? No, it's kind of cute. No. And it, they wanted some little mod for some kind of European signaling that I never heard of, but they described it enough. And I said, oh, yeah, we can do that. And then somebody else would write in and say, well, could you do this? And I said, yeah, we could probably do that. And if I could do it in less than a week or, a couple of days, I'd put the mod into the function. So there are all these weird functions that the library evolved into. I think that there's 17, something like 17 pre-configured sketches that you can still go and reconfigure. But it went to uh, controlling servos, controlling 2 DC motors, controlling a stepper
Yeah.
motor. Trying to remember what And that was the other thing. They said, well, you made this a mobile decoder. Could you make it an accessory decoder? So out came a parallel line of accessory decoders to go with the mobile decoders. And it barrel rolled and got more and more complicated. But what it wound up with was a highly configurable decoder that you can set different functions on the 17 pins. There are, like I said, at least 17 uh, uh, predefined sketches or predefined decoders in the library. About there's a couple more mobile decoders, I think, because of motor control than there are accessory decoders. But that's how it evolved. I mean, it just kept going and going.
Unbelievable.
And as a result, Alex revisited his library. There was a gentleman, actually, I think there were two people in Germany and a couple of other people that picked up on, started saying, well, why couldn't we make these such and such modifications? And then instead of just running on the Arduino, it'll run on a Teensy, or it'll run on an SAM device, an ARM device. So now he's got a lot more capability, a lot more platforms that the library will run on, uh, and they're all compatible. I think they're about 99% compatible. And he has even a version that'll run on a really small Atmel 167, which is a very small version of the chip.
Right.
So it's fascinating how it evolved. And one day I got an email from somebody who uh, was asking a question about the decoder, and he said, "Oh, by the way, our club is building 80 of these, and we're in the process now of putting them all together with all the club members, and we will probably have over 300 when we're done." And I'm like,
Wow.
"You're right." I almost wanted to write back and say, "Are you guys out of your minds?" But it turns out that these things started showing up all over the place. And people had more suggestions, and some of them were good and some of them weren't. And some of them I helped to go and make modifications for their own purposes. But there's at least a dozen different derivative decoders. Some have been laid out with screw terminals on a large board. And I was always trying to go for the smallest
Mm.
area that I could get, because I was always trying to cram them into some kind of animation. So I never tried to make it, to go with the really large Mega 2560 that's got 70
Yeah.
pins. Uh, I just never went in that direction. Uh, but I did get asked about it from time to time. And over time, people started calling, or not calling, emailing and saying, uh, the typical thing would be, "I'm sorry that my English is so terrible." And then they'd explain their problem and they said, "I'm from Croatia, I'm from Serbia, I'm from
Wow.
Kazakhstan, I'm from South Korea," and I was like, "Man, these guys are, just all over the place." And most of their English was better than most of the people that I normally correspond with in the States.
Or Australia.
So, I mean, it was really fascinating. I have a friend in New Zealand who is part of a club, and one of their club members passed on, and his spouse asked him the club members to come and see if they could dispose of all of his model railroading
Wow.
stuff.
Yeah.
And lo and behold, he had a stash of my boards there. And my friend emailed me and said, "Do you recognize these?" And I said, "Sure do." Um, but to wind up the long story, as near as I could figure, based on email and different ways of communicating, uh, there's over 1,000 modelers that have built at least one,
Wow.
and at least 3,000 of them in existence, probably more. I have no way to really know. And they've been written about or referenced in, I think, 43 countries.
Unbelievable. Unbelievable.
So it's like I said, this is one thing where I just couldn't predict
Yeah, yeah.
where it was going to go, interest
No,
level
it's great.
was. And then recently, based on the same hardware, the other thing was, I got questions about, are you, are you going to build this, and where can I buy them? And I don't build for profit anything. Everything's given away. Model Railroad Control Systems in the States is sourcing the boards. There's a hobby shop in Germany that's sourcing the boards, and somebody, and I don't know who, in the UK was sourcing the boards, or maybe the whole thing. I think the person in Germany wanted to build kits,
Right.
but I don't really know what happened with
Yeah,
all that.
yeah,
Uh, I I encourage them. It's nice if they gave attribution, but anybody could use them any way
yeah,
they
yeah.
want. Uh,
So these people are actually selling your board design. Is that what you're trying to tell me? Or yeah,
that's yeah. Now, generally speaking, they don't make much of a profit on it. They sell it for
sure.
barely
Yeah.
above cost.
Because obviously that was my next question is for some of us like myself who are no good at making circuit boards. Obviously, you would have to source them from elsewhere. Um,
Well, I think I solved that
yeah.
problem. You have one file that I provided called a .brd file, a board file, and there's a place actually next town over from where I live right now that you can send that board file to, and they will make that board for you. I think it's $4 for 3 boards, and they will ship it to you anywhere in the world, no shipping cost.
Wow. Okay.
So there are places
Yeah.
to get them. And I understand that if you source them through China, you can get them for about 70 cents or 60 cents a
Yeah.
board.
Yeah.
But all that information is provided.
Okay.
You can do anything you want with
Yeah.
it.
Lovely. Lovely. I think it's something I sort of pricked my curiosity when I was going through some of your blogs and I saw that and going, oh, I think I would like to get into that. So, how hard with someone with moderate soldering skills would be able to? Because obviously, you get the board, you've got to source the electrical components. How hard is it to solder up then at that point?
it, it it's not. Almost, except for 2 components, all of them are through
Right.
hole, which means you stick the leads through, you solder the leads, and
Yep.
you're done. And there aren't a lot of
Yep.
components. So it's really not that hard. There are 2 components that you are actually optional depending on what you want to do with the decoder. That are 2 capacitors on the bottom of the board, and they're really easy to
Yep.
solder because they're so big.
Sure. Sure.
But it's not that hard. It's nice if you knew how to solder before you tackled it, but yeah, you can do it.
And you can do it just with a stock standard sort of variable temperature soldering on. You don't need anything more than that.
Nothing special. Don't use acid core
Yeah.
solder, and the best soldering iron to use is one that has the most
Yeah.
pointy tip,
Sure.
so that you can accurately get to a pin and heat
Yeah.
it up.
Sure.
So I don't use a soldering gun, and don't use the kind of soldering iron you use to solder a copper pipe in your basement.
That's probably good advice. Good advice. Um, so you were talking about the iteration of the DCC. I think we've got it up there on the picture. Please tell me if I'm wrong there, Geoff.
Well, what you got up there is the diagram for the use of the same board with a brand new
Right.
library, relatively new library, called the IDEC
Yeah.
library,
Yeah.
which is a library I published, I don't know how many months
Yeah.
ago now, for interactive DCC decoders. Uses exactly the same hardware, but you can load, I'm not sure how many sketches are in that library, 20 something, a whole bunch. And uh, I finally was moving my way back towards animation, is the story behind this. And these were all built for me. And I was kind of getting carried away because I started doing more and more things with them. And the article that describes them has 3 videos that goes with it to describe some of the projects. Yeah, there's one. And one of the neat things that are in them is ringing a
Mm.
bell, uh, and the bell is perfectly synchronized because the decoder is doing everything, including coordinating the movement and the sound. And that's the whole bit behind the interactive
Yeah.
decoders, with one major change. Uh, when I created the decoders for use with the servo motors, people wanted to use those to control track switches. And that's pretty natural because it's about the cheapest way to
Mm.
control track switches with a smooth uh, transition uh, at very, very low cost. There's no cheaper way to do it, hands down. And one of the decoders, even as an accessory decoder, can literally control 17 servos.
Wow.
So you can control 17 track switches with something that'll probably cost you, if you make the board, about $7.
Awesome.
You just can't find
No.
that leverage. Okay, so the whole point was that what I was trying to do was to get to use these more and more for my animations. And in the process of doing that, uh, along the way, people wanted to use the DCC decoder controlling track switch servos. They wanted to use it with a panel, right? Like, so you have a fascia panel and you have a switch or you have a push button. And of course, they wanted a light indicator to designate which way the switch was thrown. The problem with that is fundamental to DCC decoders. DCC decoders are basically a one-way transmission during
Mm.
operation. They're from the base station to the decoder. The decoder doesn't transmit anything back. So if you have the decoder connected to a switch on a panel, you can make it operate the servo, but the DCC base station won't know what's going
Mm.
on.
Mm.
So the DCC base station is going to be out of sync with the actual state of the
Sure.
decoder. Well, base stations don't like that. Base stations like to think that they're in complete control and they know what's going on. So there was a disconnect there. And every time somebody pushed me, I said, if you give me a way of resolving that, I'll look into implementing that. But there's no way to tell the base station what the actual state of the track switch or the
Mm.
servo's in. And usually they gave up once they realized what I was talking about. Okay, now for interactive decoders. Interactive decoders work 2 ways. Interactive decoders have inputs, lots of inputs. And those inputs come from switches, sensors, anything external to the decoder. They don't come from a DCC base station. However, for every input that you've got that can be controlled with a switch, there is a corresponding function that a DCC base station can throw on that decoder. So you say, well, didn't you just open yourself up the same way you were trying to avoid things with the servos? And the answer is no. And the reason the answer is no is I defined actually what happens.
Right. Okay.
So if you have a switch to control a servo with one of the IDEC decoders, you throw the switch and it'll make the servo go from end to end, okay? Which is what you want. If I have the switch turned off and I use the function, and the function, when it powers up, the function on a decoder is normally 0. When I turn the function on from the base station, or from a throttle or any way you want to do it, from a DCC control standpoint, the function turns on. The decoder sees that the function is on. It flips the servo in that
Mm.
direction. Now, if I throw the switch on the panel and I turn it on, nothing happens
Mm.
because the switch is already
Thrown.
thrown.
Sure.
Okay? So now, if I turn the function off on the DCC side, so if you followed everything that I
Yeah.
just said,
Yeah.
I had the switch on, I had the function on, both on, the servo's thrown. Now I turn the function off. The servo doesn't move. If I throw the switch off on the panel, then the servo goes to the other position.
Sure.
So what happens is the on side of it takes precedent. Or if you want to be technical about it, it's a logical OR of the DCC function and the switch on the panel. And that's by definition how it works. So if you turned off the switch on the panel, you can actuate the servo back and forth strictly by the DCC function. And it'll work. It'll go one way and it'll go off the other way. But and correspondingly, if the DCC function is off and you throw the switch on the panel, it'll flip the servo. You throw the switch on the panel off, it'll go
Okay.
back. So each one can control the servo until one of them stays on and is left on.
Right.
And then both have to go off for it to go off.
Sure.
So by looking at it that way, I then define the interaction of a DCC function with a switch or a sensor or anything. And you do that for all 17
Yeah.
functions,
Okay.
right? And so once you get to that point, then you start playing games with, well, if all of this is for animation, what can I do with those functions? Well, one of the things you can do is go back to the original set of decoders and take that group of functions. Remember, I said each one you had 7 different functions you could
Yeah.
apply.
Yeah.
Well, guess what you can do? You can have the number of functions in the decoder. So you go from 17 to 8, and you have 8 switch inputs that go directly into the decoder. And you have 8 control points, 8 functions that you can control. But each of those 8 functions can be programmed by function, and you can control them with a switch, like a panel switch, or you can control them with a DCC function.
Right. Okay.
And that's where the IDEC concept came from,
Right. Okay.
is the whole nature of lots and lots of inputs to control the state of the decoder. And because it was animation, sound became a big part,
Sure.
and how you sequence sound. So the thing that's different also, besides uh, being able to control those little sound modules like you use for your crossing,
Mm.
the other thing that was added was the ability to control different tracks on the memory card on those sound modules.
Yeah. Okay.
And in experimenting with the whole thing, uh, I also found out that to control those little sound modules, you don't need all the wires that they actually advertise you need to control. You need 3. You need ground, power, and just a serial line
Yeah.
into it. And you can control those modules, right? As long as you don't want to interrogate them. You can then go in and select, you can program for sound level, you can program them for which track you want to play. And because it'll take like 32, I think it's 32 gigabyte
Cards. Yeah.
micro SD cards, you can put a lot of tracks
Yeah.
on there. Uh, Now, what I wound up doing is giving the decoder the ability to, to take, I think it's either 256 or 128 different tracks. So the decoder can arbitrarily select among those tracks and play a track at will. And uh, the other thing that was missing for animation is sequencing and timing. And that's all about um, turning something on, waiting, turning something on or off, waiting, turning something on or off, waiting. So the waiting is the delay. So I had to have a way for it to control delays accurately. Uh, and I gave it a way to control delays from uh, microseconds, which are 1 millionth of a second, actually in groups of 100 microseconds, which would be 100 times a millionth of a second, all the way to minutes.
Mm.
So you can configure it so you can create those delays to run a very wide gamut. And then, if you remember with the DCC decoders originally, uh, I used CVs, control variables, in the decoder to set what the functions did for each pin. And a lot of people wanted more and more control and were asking for more control by CV. So when I started in on the IDEC decoders, I went way in the other direction and said everything is going to be set by
Right.
CVs. So you wound up being able to control delays, timing, sound level, audio tracks, positions of servos, uh, turning motors on and off, setting the speed of motors, DC motors, all with CV settings. And why? Because depending on the decoder, um, I either group them, I think, in 8 or 8, 16. I think it went 8, 16, 64, and 100. Yeah, no, 8, 16, and 64. So what you wound up with is you could use a function or a switch, remember, either or, to turn on a sequence. And what the sequence would be, it would go and read each CV in that group. And the CV would say, turn the sound on with this volume level, uh, move this motor, move this servo, delay by a second, delay by a half a second. And it would play the sequence. And the thing that took a long time to figure out, and if you want, nobody's going to really care, but the real sophistication in all this was none of what I've talked about so far. It turns out that with these groups of sequences, you can turn on a sequence, and remember, it's a time sequence. So it's an action delay, action delay, action delay, action delay, all in those groups of what I'd say 8, 16, and 64. Um, you can start one of those sequences, and it's going to go clicking off, and then a second or a minute later, you can start another sequence, and it'll go in sequence in parallel with the one you already started.
Right.
So if you have, say, 8 groups of 8 sequences, I can actually start 8 sequences at different points in time. They're all operating in parallel with their own timing. Now, how you do that with an Arduino is a cute trick. And it actually goes back to when I worked on real simulators to like simulate integrated circuits and electronic systems. You use something called a time wheel, and it keeps track of all the time and the next time it has to do something. So it sequences each of them, even though time is going by the same for everyone. Each one is doing things at a different time, literally. So you have these different time tracks. And then I threw in another little gotcha in it by saying, okay, if you've got these groups of sequences, when I come to the end of a sequence, I can trigger another sequence. So if I have 8 groups of 8 sequences each, when I come to the end of the first sequence, it can trigger the second one, or the third one, or the fourth one. And when you get to the group of 64, there's only 2 groups because you start, or maybe it's 128, can't remember now. You run out of CVs, right? So you run out of the ability to store all this. So what happens with a group of 64? You've got 64 individual steps that you can program. When you get to the end of it, you can trigger the second one. So you can actually wind up with 128 step sequences, all controlling all these different things,
Wow.
all synchronizing the timing. And it turns out that that was the hardest thing to do. That probably took me a month to get right. Um, but you wind up with those sequences when you go and actually play the bell video. Uh, Part of the sequence in the bell video is you can speed up the bell or slow it down with different sounds, and it all tracks. And it all tracks because it's the decoder that's determining the timing exactly for each sequence. And it's got the recording of the bell gong on a soundtrack. So it just picks it up and inserts it. And you can make adjustments for the timing of how long the bell sound reverberates. And you can make adjustments for that. And it comes out really
Yeah, yeah.
great. And there's no calibration for it, right? If you play it all the time, it'll always work. You can start and stop it, and there won't be any delays or any skews. It'll always go and hit the dong right at the end of the traverse of the bell. So it literally is synchronized the way you'd like to see it
Sure,
synchronized.
sure.
Um, and then there were more things I got carried away with. The little blue diesel actually has one of those decoders in it, but it's an IDEC decoder. Yeah. And to the left of it, where you have your cursor, um, yeah, you can see that there's a speaker in the top of it, and I can't else remember what's in there. So one of those little audio modules fit in there too. It took a little while to cram it all in, but that's an old Athearn
Yeah,
Hustler, right? Now it got remotored. There's actually two motors in it, believe it or not, one for each axle. But that's all being controlled by an IDEC decoder. Now, why an IDEC decoder for that? Well, because let's see if I can see from here. I don't know if there's a bottom shot of that where the wheels are.
no,
There may be. It's too small on my screen
doesn't
right
look
now.
like it.
But on the bottom of the chassis, uh, kind of where the fuel tank ought to be, um, there's actually two sensors, and these are Hall effect magnetic sensors, and they're on either side of the chassis, right? And they barely are, like a 32nd of an inch below the bottom. Well, if you put magnets on either side of the track, uh, as the engine is going along, you can set the speed with the DCC speed control, but not the direction.
Right, okay.
It turns out one of those sensors, when you hit it, it'll slow the engine down, stop it, pause, and then rev it up in the opposite direction and reverse direction. The other sensor on the other side simply slows it down, stops it, pauses it, rings the horn, and then starts it back up
Yeah,
again as if it were stopping at a station or
sure,
something,
sure.
just to demonstrate the capability.
So how hard are you're talking about CVs and programming the CVs within this decoder? That's just done what you would say like we would normally with a normal, either a stationary decoder or a locomotive decoder.
Well, remember, a stationary decoder as an accessory decoder basically has no CVs.
Correct.
So CVs are set through a mobile decoder
Yep.
addressing, and that's what
Yep.
these have, mobile decoder
Right.
addressing.
Okay.
And you can set the CVs the way you
Yep.
normally do, which means you reprogram it on the
Yeah.
fly. Now, if you've got a sequence of 128 steps, I don't recommend you do it with your
No.
throttle, but rather sit down and work out all the
Yeah.
timing and then go and simply type in all the CVs, which you can
Right.
do, right? Whole list of CVs, and there's a little explanation next
Yep.
to them what they do.
So what interface do you use to do that then? Like
uh,
Jam?
whatever the computer you're using
Yeah.
now.
Okay. Lovely.
You're basically editing a
Yeah.
file.
Sure.
If you can compose and edit an
Yeah.
email, you can
Okay.
do it.
Fascinating. Fascinating. All right, Geoff. This has been yet again another lovely conversation. There's a lot in there that I might need to go and rewatch myself to actually fully understand exactly what you're talking about. Because, as I said, I'm a microprocessor Arduino base very early on in my career using it and trying to understand it. So just to chat with someone like you again with the amount of knowledge that you're freely giving up is just fantastic. So thank you so much for chatting with me today or tonight.
You're very welcome, and ask lots of questions. That's how we all learn.
Definitely. Thank you very much again. Make sure you subscribe, click that little bell icon to be notified of upcoming videos. Support us on Patreon, like us on Facebook and Instagram at Model Railroad Technique.